Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor. Before we begin, please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours in the Microsoft Reactor YouTube channel. Which brings us to today's session. It will run for approximately 1 hour with times for questions throughout. I will now turn it over to our speakers for introductions.
Awesome. Thank you for that. Hey, everybody. My name is Paul Yu, Cloud Native Developer Advocate here at Microsoft. And I'm coming to you live from the city of Los Angeles, California. It is about 8 in the morning over here. So wherever you are in the world, post it in the comments there. Not sure if it's early or late or whatever, but I hope you're here to have a good time and have some fun with AKS. This series is actually the first of 8 episodes that we're going to deliver on the Microsoft Reactor channel. The AKS team has actually published a whole website just dedicated for AKS labs. And so we're just going to be running through 8 labs or so. And today in this session, we're going to go over, we're going to go back to the basics. We're going to talk about Kubernetes fundamentals, and we're also going to talk about AKS fundamentals along the way. Okay. So hope you have some fun here. And I'm going to show you my only slide that I have. Actually, I only have 3 slides, but let's see. Click through. That's it. So we're just going to go right into the workshop. For those of you that are hoping to see slides, I'm sorry about that. I don't have any. We're just going to jump right in. So let's see from the chat. I'm looking here. Wow. Okay. A lot of people from all over the globe. So welcome, everybody. And it looks like for the most part, got some people in the morning over there. Cool. Cool, cool, cool. Okay. So hope you all brought your coffee. I know I did. So we'll get started. So what you want to do here is basically, I'm going to show you the, I'm actually going to bring up the website. I'm just going to type it here. So you want to go to https://aka.ms/AKS/labs. I know it's a lot there, but that's basically the URL. And we'll probably post it into the comment section over here as well for those of you that want to follow along. And that's the whole point of these labs, right? We just want to get our hands dirty, play with the technology, and yeah, have some fun. So navigate to this website, aka.ms/AKS/labs, and you'll get dropped into this little workshop website here. Okay. From there, just click on the workshops link at the top over here, and that will take you to the menu of all the workshops that we have available. And you can see that we have them kind of organized by different categories within AKS, because AKS is a big product. Kubernetes itself is a humongous project. And so there's just a lot to cover, right? And so we have that kind of like organized. So depending on what area most interests you, we probably have a lab for it. And if we don't have a lab for it, let us know in the GitHub. So this is all backed by an open source repository. And so what you can do is you can actually click on that GitHub link. It will take you to the repo where we're actually hosting this stuff from. If you see any issues, if you have any ideas, if you want to contribute, feel free to come over here, open an issue, and let us know your thoughts. Okay. So if I jump back over here, the lab that we are going to do today is going to be getting started. Okay, so you want to open up the getting started menu and then come down here to Kubernetes and AKS fundamentals. Jump over to this Kubernetes and AKS fundamentals section, and then you'll see some right-hand navigation. This is actually all of the sections and subsections as part of this lab. And then your left-hand navigation is just site navigation. So what you can do is you can actually, you see that little button down there? Once you're in a lab, click that button and it'll move away that side menu. So that's pretty cool. This is all built by DocuSource, which is another open source project. And so it's pretty cool. I would say for this lab, like I mentioned, going back to the basics, Kubernetes fundamentals. I know AKS, we aim to make things a lot more easier so you don't really have to think about Kubernetes as much. But me, myself, I'm admittedly a Kubernetes junkie. I've been working with Kubernetes and the terminal and kubectl for many years. And I'm actually a Kubestronaut as well, which is basically someone that passed all of the Kubernetes certification exams. And so I thought maybe we should build a lab that will teach folks the fundamentals, some of the fundamentals of Kubernetes. And so what I did was I basically outlined this workshop to align with a lot of the domains and competencies that come along with the Kubernetes certified application developer exam. So if you scroll down here, and if you're interested in taking the exam, this is the place that you would come to learn about what's in the exam, how you can prep for the exam, and give you some pointers as to what you would need to kind of study for. Okay. It's a really good and rewarding experience, especially those that are just getting started with Kubernetes. This will definitely get you hands-on into that. So, like I mentioned, this workshop is outlined with pretty much the same guidelines as what that CKAD is, but I would say, and I just want to stress that this workshop is not a full guide to pass that exam. You won't be able to pass that exam by taking this workshop, but you will have a solid foundation to say, okay, I know what to do and I know how to study, and I'm familiar with some of these concepts and some of these commands that you need to be an expert at in order to pass that exam. So yeah, basically give you a solid foundation here. And oh, I see I have a typo, so I'm going to fix that after this call. All right, so let's get started. So here we're going to cover a lot of things because we have a lot of things in the domain competencies that we want to cover. And so we're going to do things like setting up a workshop. Okay, so this workshop is all about using Kubernetes and using AKS, not necessarily setting it up. And so we're going to provide a Azure ARM template for you to deploy all the resources, and then you can just start playing right away. Okay, so what we need here to get started is to basically, you're going to need a lot of tools installed. Okay, so what you're going to need is VS Code with a couple of extensions. Okay, and these are all clickable in the workshop materials, so go ahead and click on them and install them. Hopefully you all have VS Code installed already. So you'll need the AKS extension, the Kubernetes extension, and the Container Tools extension, which is formerly known as the Docker extension. I see somebody saying the URL is not working. Which URL are we talking about? Maybe I'll post it in the comments here. https aka.ms AKS labs. I just want to, yeah, it is. So labs. Okay, I'm unable to comment here, but then I'm just going to type it here one more time on the screen. https aka.ms AKS labs, plural. Okay. So that's where you want to go. And I'll just leave this up for just another second or two. Okay, cool. All right. I see some folks are in, so I would provide the real URL, but it's a pretty long URL, but this short link will totally get you there. So, okay. And okay, so people are saying it's working. Cool. All right, so I'm going to move on. So what you're going to need is Visual Studio Code with the extensions, and then you're also going to need Docker Desktop. You could get away with Podman Desktop if that's your choice, but do know that the instructions are written using the Docker CLI, and so you might need to turn on the Docker compatibility mode on that. You'll also need the Azure CLI because we're going to be connecting to the AKS cluster and doing some things around that. You'll also need kubectl. That's the command line to basically talk to the Kubernetes API server. And then for application deployments, we're going to play with Helm, and we're also going to play with Customize, the two things that you need to be familiar with. And then we'll also need Draft. Draft is a pretty cool tool. So if you've never containerized an application, you'll see how Draft can really help you there. And then you'll need things, well, importantly, this is like super important here. I write most of my instructions. Actually, I write all of my instructions using a POSIX compliant shell. So what is that? That's bash, ZSH. And so if you're on a Windows machine, you might want to open up or install WSL on your machine. Or if you have Git installed on your Windows machine, I think there's Git bash that you can use. But all the instructions are written in bash. So that's that. And then with bash, along with bash, you get tools like JQ, which allows you to parse JSON and all that stuff. So the first thing that you need to do, and I'm going to be flipping back and forth between this and my terminal. First thing that you need to do is, oh, and one more thing. This is super important. These labs are BYO subscription. Okay. So you need to have an Azure subscription, and you need to have the proper permissions to create resources and to assign roles within that subscription. So typically a subscription with owner privileges, that's more than enough. You could get a little more granular with the permissions, but I'm not going to cover that now. But yeah, you are expected to have your own subscriptions. Now, we often deliver these labs at like events like KubeCon or AKS Day, the pre-day event before KubeCon, or at Microsoft Build, which is next week, or at Microsoft Ignite. And we will offer you a subscription over there to play with. But here, if you're just working off of this workshop URL, you are expected to have your own subscription, okay? So in order to get started, what we're going to do is we're actually going to log in to the Azure subscription through the CLI, and then install AKS preview extensions. And then from there, what we're going to do, and I'm just going to show you this because I'm just going to run through this really quick, is I have an ARM template down here, okay? And that's this right here. But in order to deploy that ARM template, I need a resource group, I need to choose a location, and then I need to deploy my resources into that. And so all I'm doing here is basically randomizing or creating a random identifier, because some of these resources in Azure, they need a globally unique name. And so this helps me get that globally unique name. And then I'll set the location and all that. So let's go and log in. So if I jump over to the terminal, go ahead and log in. I'm already logged in. Okay, it will do that. Cool, logged in. Nope, this way. All right. Okay, so what we'll do from there is you'll need to install the AKS preview extension because some of the features and functionality within the Azure CLI requires that. I'm not going to run through that because I already have that installed. And then what I'm going to do is I'm just going to copy and paste the random variable setting command. I'm going to choose a location, which I'm just going to pick a random location. Let's just say UK South. But pick a location that's close to you. And then I'm going to create a resource group name. And then I am going to actually create that resource group using the AZ group create command. And then here you can see I'm passing in the resource group name and the location. So we'll go ahead and do that. And then from there, we'll actually deploy this ARM template, okay? And so we're going to pass in the resource group name again. We're going to give the deployment a name, and then we're going to pass in what's called the template URI, which is basically the JSON file, okay? Here, we're also passing the random seed for unique resource names. And then the user object ID, which is my user object ID, you can see I'm getting that in like a subquery over here. And so what this will do, it will pass in my user object ID into the ARM template so I could make the proper role assignments. Okay. Let's see. Now, this is going to take a few minutes. So while it's waiting, I already have an environment already stood up, so we don't have to sit around and wait for that. And so what we're going to do is I'm just going to flip over to the new assignment. But this will definitely run, and it'll eventually come back. Okay, so I'm just going to bail out of that. Now, what will that do? Well, that's going to create a bunch of stuff for you. It's going to create a AKS cluster, a container registry, manage Prometheus, manage Grafana for observability, log analytics, of course, and then some other tools where you can kind of play around with. So what I'm hoping here is to give you a big playground to play with. You'll get Key Vault, so you can play with secrets over there. The app configuration store, which is kind of like a little known service, right? To manage configuration outside of the cluster. It's pretty cool. And then there's an AKS integration over there. And then Cosmos DB for a demo application. And then, of course, a user assigned managed identity. Okay. Very, very important here. Okay. As we're deploying all these resources, in the ARM template, there's a lot of output there. So there's all these resource names, like all the like the Grafana name, the MongoDB or the Cosmos DB name. So we can actually export that, and we can export it from the outputs of the template. And so if for any reason you open a new terminal or you're in a different environment, you can always just set the RG name and then run these commands down here to get all of your environment variables back. So let me show you what I'm talking about. So here I have my resource group, and it's actually populated with all the services that I talked about, right? And so all I can do is I could just copy that and, oops, wrong direction. Let's do this. RG name, right? So all I got to do is just set that RG name. And if I jump back over into my instructions here, this will eventually pull all that information out. And if you're wondering what that is actually pulling from in the Azure portal, down here under deployments for the resource group, you can actually click that. You can see that I do have a deployment that I ran yesterday. And then there's a bunch of outputs, right? So AKS name, node resource group name, ACR name. So all that stuff is being pulled out of this particular deployment and then set as environment variables. So that's what's really going on over there. Okay. So once you have that all stood up, we're basically ready to dive into Kubernetes and understand and play with Kubernetes, right? And so I don't explain a lot of the concepts here because there's a lot of great documentation on the Kubernetes site. And so throughout this workshop, you'll see links that shoot out to the Kubernetes resources. And so you should definitely pause and go take a look and read through some of those high-level concepts. This stream is definitely recorded, so you can always come back to it on the Microsoft Reactor channel or even on the AKS community channel. So we're actually streaming to both channels on YouTube right now. So definitely pause the video, go out, come back, fast forward, all that good stuff. Okay. So let's just really quickly talk about high-level Kubernetes architecture. This is actually taken from the Kubernetes documentation itself. So the cluster itself is comprised of two different things. One is called like the control plane, and then the others is called like the agent or worker node pool. Okay, so basically the control plane is the brains of Kubernetes, right? It has a Kubernetes API server, right? The Kubernetes API server is a way for the nodes to basically talk to Kubernetes and submit your manifests or your declarations into Kubernetes, and then Kubernetes actually stores all that stuff in a key value data store known as etcd. Okay, the Kubernetes API server basically handles the inputs and outputs of the data coming into the Kubernetes cluster. And then you have things like the scheduler and the controller manager that tells Kubernetes like where to schedule the workloads, right? And inside of each node, because Kubernetes can have multiple nodes and multiple node pools, basically the node has what's called a kubelet that goes and talks to the Kube API server, and then it understands, oh, I need to go schedule this application on my node. So let me go ahead and pull that container image down and schedule that. And then at the end of the day, what you have effectively is pods running in your nodes. Okay, that's just a very high level overview of Kubernetes. We also have what's called a cloud controller manager. This is oftentimes implemented like in the Azure cloud, Google, AWS. And this allows you to interface with the clouds, of course, because when you're running Kubernetes, a managed cluster in the cloud, you want to take advantage of some of the cloud resources, and we'll have the opportunity to do that with like Azure storage and things like that. Okay, so I would say on AKS is a managed service, all this stuff in the control plane right here, this is all taken care of for you. You don't have to set that up. If you're running Kubernetes on-prem or just even in the cloud by yourself, you would have to set all this up, and it's a lot of work. I've done another workshop where we actually set up a cluster from scratch, and it's a lot. So it's good to know that AKS will actually manage that for you. The only thing that you're responsible for doing is just spinning up your node pools and then nodes within it. Okay. All right. Moving on from high-level cluster architecture into application design, or excuse me, application build design and deployment. The number one thing that you need to know is that Kubernetes runs containers, okay? And in order to do that, you need to make sure you have a containerized application. So what we'll do is we will, let me just cd into a temp directory here. I'm going to clone a sample repository called the Contoso Air application. And I'm going to open that here. That looks good. Okay. And because now I'm in a new terminal, I got to do that stuff again. RG name, I think that's it. Export, yeah, I think that's good. Okay. Which way am I going? I'm going to move this around just a little bit. Sorry for the jumping around here, but I'm going to move that around. Okay, cool. So what we can do is take a look at the code here. You can see it's just a Node.js application. Let me drop that down. And it's basically a sample flight booking application where you can book flights to fictitious locations. But if you look through the source code there's no Docker file. And so that's the first thing that you need to do when you want to get started with AKS or even Kubernetes is you need to containerize your application. Now, containerizing your application could be a little daunting for folks that are just getting started. But what you can do is you can actually leverage a tool called Draft, and you can actually have Draft one for you. So what I'm going to do is I'm just going to run this command, which will basically cd into my SRC web site, and then I can use Draft. Remember, that was one of the prerequisite tools that you needed to install, and have it create the Docker file. It does a little bit more. You can actually create a Kubernetes manifest as well. But we're only going to generate the Docker file for now, okay? And so what I'll do is I'll run the draft create command, and I'll ask it for interactive, and you can see that it's detecting that it is a JavaScript application, and then it's going to start asking me questions about the application. So please enter the port exposed on the application. Well, it's a Node.js application, and that's exposed on port 3000. And then it says, please enter the version of Node that the application is written in. The default is Node 14, which is rather old. So I can just say it's using Node 22. Okay. So now you can see here that I have a couple new files added to my repo. One is the Docker and the Docker ignore. And if I just open that up, you can see I have all the commands needed to build my container image, which is pretty cool. Now, just a caveat here, Draft will help you get started and kind of like lay out the basics of your Docker file manifest. Is this the best, most production ready container image? I would say no, because you would need things like, well, depending on the application, you would need things like multi-stage builds, right? Because a lot of times you want to build the application and then you want to host the application, and you don't want all the binaries that get collected along the way. And so you would want to run, this is great to get, okay? Now, with the Docker file created, we can run some Docker commands, okay? And so we can do things like Docker build, and we need to actually tag, right, with what the actual image name will be, and then the version. We're using latest here because this is a demo environment, but typically in a production environment, you want to actually use semantic versioning for that. Okay, so I'll just run through that command there, and it will take a few minutes to actually build the application. And then it says something failed. So what failed here? Bum, 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 bum. Okay. I did update my Docker right before this live stream, so that might be an issue. Okay, no problem. That would actually take me to another part. So if that actually built, you can actually do a Docker run command. And yeah, I think it's probably has something to do with me updating Docker desktop right before I jumped on the stream. So I probably shouldn't have done that. But you can actually do a Docker run command and basically port map your 3000 on your local host to the 3000 in the container, and you'll be able to browse the site. Okay. But what we can also do is we can actually use ACR or Azure Container Registry to actually build the image for us. All you have to do here is just log into the ACR and then tag your image using the ACR URL. And then you can actually tell ACR to build the container for you. It won't build it locally. It's actually going to send the package up to the Azure Container Registry and do that for you. So let's go ahead and do that. It's a good opportunity to show that. Okay, so let's do this. Clear the screen. We're going to log into the ACR. Okay, login succeeded. And then what we're going to do is we're going to tag the image. We're going to tag it with the ACR name. So it's the ACR name .azurecr.io, and then with the Contoso Air in the latest tag. And then we're not going to push because we don't need it to push. We're going to just tell it to build. Okay. So ACR build, and then you pass in the registry name, and then you pass in the image name. And then I'm just going to say no wait because I don't want to wait on it. I'm just going to let it go. And then we'll come back and revisit that in just a little bit. Okay. So once you have your container image or your Docker file written, your containers building, obviously you want some sort of CI/CD going on to automate that process for you because you don't want to sit there and run Docker build all the time. So you would eventually want that to happen. The next thing you need is once you have a container image in ACR, you can then use that to actually deploy a pod into your Kubernetes cluster. Okay. And so we'll go into that here. This is where you can kind of read about Kubernetes being a container orchestrator, but Kubernetes doesn't run containers directly. It actually puts a container in what's called a pod, which is the smallest deployable resource in Kubernetes. And inside of a pod, you can have multiple containers actually. And the pod allows the containers in there to basically share data, share networking, and all that stuff, right? And so here in this section, we'll talk a little bit about what the Kubernetes workload resource types are. So pod being the smallest thing. But even then, you don't want to manage pods on your own because Kubernetes doesn't have a concept of like restarting pods, right? And that's the whole point of Kubernetes is you wanted to orchestrate your containers and you wanted to deploy new containers as containers fail and things like that, right? And so what you would typically do is, depending on your application, you would typically use a deployment resource, which is basically almost like a high-level wrapper for a replica set. And so a replica set basically allows you to say, I want pod A or my Contoso AirPod, and I want to run 5 replicas of that, right? And if for any reason something goes down, one of the replicas go down, the replica set will basically restart it. And so you'll always have Kubernetes kind of like in this loop, checking to see if you have enough replicas and spinning up new pods if it's needed, if the desired replicas don't match the actual replica count, right? And so you definitely, this is one of the deployment or one of the workload resource types that you're going to work with most often, okay? There is a replica set here, but you often don't use that because you allow the deployment to manage the replica set. We also have things like stateful sets. So deployments are typically for stateless workloads, things that could go up and down really easy. You don't have to worry about any of the data. But if you do need to worry about the data and making sure that the data persists beyond pod reloads or container crashes or whatever, then you would want to use something like a stateful set. If you want to make sure that your pod is running on every single node in your cluster, this is great for like things like logging, then you would want to run something like a daemon set. And then of course we have kind of like batch resources, which is a job or even a cron job. And the job basically is a small little container that runs to completion, right? So just think of like processing things off of a queue and whatnot. And then a cron job is just like a job, but it runs on a schedule, okay? So in order to work with the Kubernetes cluster, because we've deployed one, and hopefully yours deployed by now, what you can do is you can actually run this command, which is the AZ AKS get credentials command. And what you need to do is just pass in the resource group name and the AKS name. And what it's going to do is it's actually going to download a file called kubeconfig and then place that into your local directory. Okay, this kubeconfig is it's a pretty powerful file, and I show you in the instructions over here. So if you take a look at the kubeconfig, you look at the raw. So you see a lot of like certificate data in here, right? So client certificate data. There's a lot of stuff in there. The default authentication mechanism of Kubernetes is through the use of certificates. The Kubernetes cluster itself has a CA server that can actually issue certificates. And so when you do that AZ AKS get credentials command, what you're doing is you're pulling down a certificate. That certificate is tied to a user in Kubernetes, and that user is pretty powerful. That user is a cluster admin, okay? And so you can see all the different configs that's in your kubeconfig file because you can connect to multiple clusters at the same time. And so what you can do here is basically, let me show you one thing. You can actually use the Kubernetes extension over here. This little extension. And then what you're going to see is you're going to see all the different clusters that you are attached to. And you can actually manage And I know I do this all the time. I connect to so many clusters. This list becomes really long, and cleaning up your kubeconfig can get a little tedious. And so I like to use this Kubernetes extension. And if I need to delete a kubeconfig, I can just come here, right click, and say delete kubeconfig. If I want to use this this particular cluster, I can right click in and say set as the current cluster. So this is a pretty cool and intuitive way to kind of like switch context between clusters. So that's just a little tip for you there. Once you are connected to the cluster, you can actually start to view all the API resources that's available. So let's just clear the screen there. And so one command, and this is actually the command line tool, kubectl. This is the thing that you're going to work with a lot, especially if you're digging into the CKAD exam. And so you can actually run a command like kubectl API resources. And let me just hide this a little bit. This will actually give you a listing of all of the Kubernetes resources that are available to you. And a pro tip here, take a look at the short names because they're going to save you on some key commands, right? And what I mean by that is if you're working with config maps, you can just type CM instead, okay? And then they also tell you if it's a namespace resource, yes or no, okay? I see Pixel Robots in here, KubeTidy. Ah, yes, KubeTidy. So that's a pretty cool tool. Go check it out. Pixel Robots is working on a project called KubeTidy, which is off of the kubedeck.org, I believe. Anyhow, it's a cool UI tool that allows you to work with kubeconfig and tidy them up, hence the name. So that's pretty cool. All right, so let's just move on here. kubectl, super powerful. So you saw that the kubectl API resources command will give you a list of all the things that you can actually deploy into a Kubernetes cluster. Now, what does this kind of like do? Well, let's just say I want to make a deployment because I know a deployment is where I want to deploy my stateless application. And I need to generate a Kubernetes manifest. And oftentimes you don't really know where to start with some of this stuff. You could use things like Draft to basically create the manifest for you. You can also use Copilot, probably in ask or agent mode, to ask it to help you craft a manifest for you. But one of the things that I really love to do is I just like using kubectl to generate that. And here's why it can actually help you. So if you're looking to deploy a Kubernetes deployment, you can actually ask it, explain deployment to me. And deployment is actually going to go through all of the fields within this API because every single resource is an API in Kubernetes. And it'll start to explain things within the deployment. And then just think of this as a tree structure, right? So if I want to know about the deployment spec, I can just basically run, and I'm just going to clear my screen again. Hold on a second. I can run the command again. Oops. Explain deployment. And I can say spec, right? And then it'll dig one level deeper and it'll show me everything about the deployment spec. And then if I want to go all the way down to like, how do I configure my container? Well, it's gonna, basically I can traverse that tree structure and understand all the little fields in there, understand how to put that together, and it'll give me a bunch of information on that. If you want a very high level listing of all the different things that's in a deployment, you can do the explain deployment, and then you can pass in the -- recursive. It'll give you all the fields, and it's a lot. So eventually you'll probably end up working with all this stuff, but for now, in our simple Contoso Air deployment, it's not that complicated. And so what we can do is we can actually use the kubectl create command, which is basically an imperative command. Imperative meaning I'm telling kubectl exactly what to do and how to do it, but you can actually pass in this little flag here, the dry run equals client, output YAML. You can use an imperative command to make a declarative manifest. So it's pretty cool. So what I'll do is I will create a manifest directory, and then I'll do this right here. So kubectl create. I wanted to create a deployment called Contoso Air. I'm passing it the image name, right? This is the image that that we just sent up to Azure Container Registry. And I'm also doing the port mapping, right? So I want to make sure that the container runs on port 3000. And then, of course, I have these special flags that I could run to generate the manifest for me. And so once I've done that, if I hop over here, if I go to manifest, look at this. This is pretty cool. So now I literally just used kubectl to generate this 26-line deployment manifest for me. Okay. Obviously, there's a lot more things that you could do to this manifest to make it more production ready, but this is a great place to get started. If you use things like draft will include a little bit more best practices in there. One thing being the resources section here is blank. And we talk about that a little bit at the bottom of the workshop around why you would need the resources section filled in. But as far as this goes, we are actually ready to deploy the application. And so what I can do is I can actually come over here, open up my terminal again. We'll expand that. And here, now we're just running another kubectl imperative command, basically saying to apply this manifest into my cluster. Okay. So once I do that, you can see that the Contoso Air app has been created, and I can do something like get pods and then watch. So you can see here, I have a few shortcuts, right? So I'm lazy. I don't like typing kubectl all the time, and so I've aliased it to K. I'm also lazy, and I don't want to type PODS all the time, and so you can just type in PO, right? Because a lot of the resources in Kubernetes, they'll have a short name, and so rather than spelling out the whole thing, now pods is a bad example. It's just 2 more letters, but something like deployment or service account or config map, I mean, that's kind of stuff I don't want to type all the time. So you can actually shorten it, and then you can actually pass in a thing like -W for watch, so you can watch the deployment. So we can see here that the thing is running, and it's been running for about 15 seconds now. I can actually now test the application. Okay. We talk a little bit about networking towards the end of the workshop, so go take a read through that. We have a deployment, which basically deploys a replica set, which ultimately deploys a pod. But that pod is not accessible to the outside world or outside of the cluster. And so what we can do is we can run a port forward command, which will forward my local 3000 port into the container so that I can browse to it as if it's an application that's running locally. So I just came here, ran a port forward command. And if I jump over here and I go HTTP localhost 3000, you can see that the application is basically up and running. So just using tools like draft and to create your Docker file and also create manifest. But I mean, you can definitely use kubectl to create your manifest. We're able to get an application just up and running on Kubernetes, which is pretty cool. Okay. Let's see. There's a lot of stuff in here. Okay. So I'm not going to finish everything. And it's probably going to take you just a little bit of time to finish everything as well. But there are some things that you should consider when designing your pod deployments, right? There's this whole concept of like sidecar containers. Remember how I mentioned that a pod can host one or more containers? You would want to do something like that, something called like a sidecar pattern for things like logging, networking, If you heard of projects like Dapper, I mean, that's the way Dapper runs. And so basically, if you deploy something here, right? So here's a little Sidecar demo. You can see down in my deployment spec, right? I have a list of containers, okay? And within the list of containers, you can see I have one container called my logger, and then I have another container called log shipper, okay? One container actually will just, in a continuous loop, write the current date and output it to a text file, while the other container basically does a tail on the text file. So it's basically, remember how I said within a pod, containers can share the same networking and storage. So it's basically the concept here. One is writing to a file, the other one is reading from the file. And so what you can do is you can actually run a command like this. And I'm just going to stop the port forward. I'm going to clear the screen. Okay. You can actually run something like that and get that deployed. And then from there, you can grab the actual pod name, and then you can see all the logs within that. So here in this command, I'm getting the pod name for the Sidecar demo deployment, and I am actually doing a kubectl logs on the pod, and the -c log shipper basically tells me I want to view the logs of my log shipper container, right? Because remember, there's two containers in there. And so you can see that it's actually writing to that, and we can see how this sort of design pattern works pretty well. And it's used quite often, especially during logging scenarios. So that's that. So now I just want to point out here, typically, you would write the manifest to a YAML file, and then you would pass the file into the kubectl apply command. Over in kind of like the bash world, you can actually write what's called here docs, where basically you can write the manifest, and then you can redirect that content into a previous command. And so just for demo purposes, it's just easier for me to write the instruction this way. But ideally, you just want to write all your manifests out into an actual file, source control it, all that other good stuff. Okay. The other thing I want to call out here is the file that we're working with. The file is actually mounted into the pod as a volume, and that volume is basically set to empty dir or empty directory. Okay. This is ephemeral. If the pod goes away, so does the data, right? And so you can see how that can pose a problem, especially if you have important data, right? And so what you want to do here is you actually want to use persistent volumes, right? PVs or PVCs is what they call them. Actually, it's two concepts, PV and a PVC over in the Kubernetes world, okay? Normally, what would happen is an administrator would create a PV, which is basically like a allocatable block of storage. And then your application will put a claim against that PV and say, hey, out of this block, I need like 1 gig of memory or 1 gig of storage on that. And so you can go about it that way. But as you're working with AKS, you want to leverage this thing called storage classes, right? And within AKS actually provides a whole bunch of storage classes that where the AKS team actually wrote CSI drivers to provision Azure storage resources. So we're talking about cloud resources now, and it can actually dynamically provision the storage resources for you. And so these storage classes actually come with every single AKS cluster, and you can do a get storage class. Let me just hide that. And you can see all the different storage classes available for you. So if you need Azure files for Azure File Share, you can leverage some of these Azure File CSI drivers or storage classes. If you need like managed disk from Azure Managed Disk, then you can take advantage of the managed CSI storage classes. And so let's just quickly show you how this would all work. So remember how I said typically administrator would create the PV. You don't need to create the PV, especially with AKS with these storage classes. All you need is to create the PVC, the persistent volume claim, and you need to pass in what storage class you want. That storage class knows how to dynamically provision the resources for you. And so what I'll do is I'll actually go ahead and create that PVC. And then from there, boom, 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 I can delete the actual Sidecar demo deployment that we previously had. Remember, it was using an empty directory. And so I can now redeploy this. This is nearly identical, right, as the previous. But instead of empty dir, what I'm doing is I'm taking a PVC, mounting that as a volume in my pod, and I am basically passing or telling it to use the PVC Azure file, which is the PVC that I literally just created. So if I go here, what I'll do is I'll just redeploy. That's all good. That's there. And if I just do a get PVC Azure file, you can see here that the status is bound. That means that the CSI driver was invoked to go create that PV for me. And so now I have a volume that's available that's by this name with all the gobbledygook in there in the name. And so what you can do is you can verify that this stuff is actually provisioned within your Azure subscription. And so you can do things like go find all the storage accounts, right? That's within my AKS node resource group because AKS manages a resource group for you. And you can see here that, yes, I indeed have a, that's not what I want. I have a Microsoft storage account created, and it's using the standard LRS. And you can see within the tags that it was created by Azure. So I definitely have an Azure file share available in the Azure portal now. And if I want to go see the actual file, I could run these commands. But let me show you how you can actually see that from the Azure portal. So the cluster was deployed into my resource group 13023. I can actually go to the MC resource group. That's typically the MC is like a signal for managed cluster. And so if you go to the MC resource group, you can actually come down here, find the storage account. Okay. You can hop over to the file share. And then that's all blurred out now, but that's basically the PVC that was created. And then browse. Okay. And then here's my log file, basically. So everything that Sidecar demo app is creating, that's all being written to the log file within this Azure storage. And so you can see here now I have persistent storage, and I can deal with applications that require that pretty easily with the AKS storage classes. Okay. Now, let's see. What else do we have here? Application deployment. And I'm probably going to go through this application deployment really quick because I just want to show you. Within Kubernetes, labels and selectors are a very powerful thing. And let me show you why. You can actually use labels and selectors to basically deploy your applications in like a blue-green scenario or even a canary scenario. And so you can do things like this, and I'm just going to hop back while that gets created, is I'm going to deploy two versions of Nginx, okay? One with blue text and one with green text. So it's very simple. And that text is actually going to be stored in a config map. And you can see here that I have Nginx blue, and my color is set to blue. And if I scroll down here, that's my deployment that uses the volume again. But this time you can actually mount a config map as a volume. And over here in Nginx green config map, my color is set to green, right? And then I deploy an Nginx green deployment. I'm mounting the volume over here. And then what I can do is I've deployed the config maps and the deployments. I can actually expose the application via service, right? And we talk about that in the workshop later. And what I can do is I can just wait for the IP to pop up. And once that is popped up, I can browse to it and click on that. And of course, it opened in the wrong browser. So let me just copy that and paste it over here, right? So that's Nginx blue because I deployed, I actually exposed the service using the app selector of Nginx blue, okay? If I want to just illustrate that for you real quick. So this is basically what happened. I have a pod that's called Nginx Blue, and I know some of you, it might be a little too small, Nginx Blue, and I've added a label to the pod where the label is app equals Nginx Blue. For my Nginx Green pod, I've actually given it a label of Nginx Green. Service, you can actually tell a service, right? Just think of it as a load balancer. You can think of it as directing traffic to a specific group of pods just based on the labels. And so here the selector is Nginx. Let's see, hold on a second. Here the label is Nginx blue. And so all the traffic is directed to the blue pod. If I were to change that to Nginx green, what the service would now just point to that. And so this could kind of give you a very primitive way of doing blue-green deployments, just all within Kubernetes, just by using labels and selectors, okay? The other thing that you can do is you can actually, meaning you're going to actually deploy 2 versions of the same app and slowly migrate traffic over to the new version. And so this set of exercises here will basically update the app. Actually, not that. I'm going to do this right here. It's actually going to update the app to add a new label. And the label is just going to be more generic. The label is just going to be, where is it at? The label is going to be, I think I called it project. Project equals my Nginx, right? So, and then the selector is my Nginx. And so what's happening here is now I have a service that actually routes to both, right? And so in order to basically implement the canary, let's just say I have 2 pods over here, and then, oops, nope. I want to copy this, copy, paste, yeah. Okay, and then let's just say I just deploy 3 replicas, right? So now I'm gonna have traffic going to both. And then eventually what I can do is I can actually start spinning down the blue, right? Because I'm going from blue to green. And so what I can do is I can delete a pod, and then I can basically scale that thing down so that once the traffic, once I'm happy with the results of my, let's say, A/B testing or whatever internal testing you have, I can actually spin down all of the blue, and then eventually all the traffic goes to my new pods, right? So that's basically what is the idea around blue, green, and canary on Kubernetes. So if I just patch my service one more time, and then if I scale the replicas, right, as I mentioned, what I can do is I'll just run a continuous curl command. And you can see that everything's going to green. You'll see a few hitting blue. Yeah, you see just the few because I have basically a 1-to-3 ratio. So most of the requests are going to green. I'll stop that. And then what I can do is basically eventually scale down the blue replicas to 0. And then if I run that curl command again, now everything is going to green. Okay, so that's primitive way of implementing Canary, all using Kubernetes resources. There are some other things that you can implement using more advanced tools like Argo rollouts or Flagger. And so that's definitely things that you should look at. Okay. Let's see. I think this is a pretty good stopping point here. Hopefully you had a pretty good taste of what Kubernetes is and how to get started and how to deploy your apps, I would highly recommend that you go through the rest of the content, because there's a lot of stuff in here. We do talk about using config maps, using secrets, Kubernetes secrets, Kubernetes config maps, and then also a little talk about using the secret store CSI with Azure Key Vault. And so all of the resources are in this lab environment for you to kind of like explore. And then I also drop a lot of links in the workshop content that allow you to just kind of like go off and do little side quests and go play with the cluster and do things. So I would say play with that. There's a lot of stuff that went in here. Feel free to reach out if you run into any questions along the way. You can probably, you can find me on LinkedIn. My DMs are always open. And so if this was something that was valuable to you, just let me know. And if there's something that needs to be fixed, let me know. I would definitely be happy to help you with that. And so I think we are basically at time for today. And so, yes, I would say just continue on, play with the cluster, do your thing, and tune in for the next one. So like I said, this is the first of 8 workshops that we're going to go through. The next one will be delivered on May 27th. Same time, same host. And so in that lab, we'll talk a little bit about Kubernetes the easy way with AKS Automatic, right? In this lab, very terminal heavy, very kubectl heavy. And the next lab is going to be more for like the people that are like, hey, Paul, that kubectl stuff is great, but I don't care about it right now. I just want my app on AKS. And so I'll show you that. In the next lab, I'll show you how you can get started with the AKS Automatic cluster using the same demo app with very minimal kubectl. So hope you all enjoyed this session. I would say tune into the next one and go to this URL here, aka.ms/AKS/reactor for a listing of all the upcoming sessions, and click and register. So hope you have fun. I had fun, and I'll see you on the next one.